What's going on, guys? In this video we are going to see how to solve a Bernoulli's differential equation. First of all, we have to know how does the standard form of Bernoulli's differential equation look like. This look like this one: y prime is equal to a of t y plus f of t y square. Right? This power should be greater than 0 or 1, and here we have that is greater than 1, and y prime we have this in standard form, and also a of t is going to be whatever the function we have before this y, and here that's going to be a cos t plus b. That's going to be our a of t. So let's note that one down. This is our a of t, and then we have to have f of t. So after this, whatever the y power we are having greater than 1, before that we have minus 1, right? So that's our f of t right here. So this minus 1 is f of t. And then after we figured this one out, what we have to do is we have to use z is equal to y power 1 minus n. Here the n value is going to be whatever the power we are having for the y, the highest power. So this is going to be our n value. Right, now we can go ahead and write z is equal to y power 3 minus, actually 1 minus 3. That's going to give us y power negative 2. Now after we found this one out, we can write everything in terms of z like this: z prime is equal to 1 minus n a of t z plus f of t 1 minus n. Now let's go ahead and write it. So here we are going to have z prime is equal to 1 minus n. 1 minus, we know that n value is 3, so this is going to be 1 minus 3, and a of t, we know that a cos t plus b is the a of t, so we plug that one right here, a cos t plus b, right? So this is our a of t. After that, instead of y, we plug z right here, so we put z right here, and after that plus f of t, and we know that f of t here is negative 1, so we put a negative 1, and that one multiplied by 1 minus n. So 1 minus n value is 3, so this is going to be multiplied by 1 minus 3. Now let's go ahead and simplify this one. This is going to be minus 2 a cos t plus b times z, and then we have minus 1 times, this is going to be minus 2, right? Minus 1 times minus 2, that's going to give us plus 2. So this is what we are going to have. After that, what we have to do is we have to use the integrating factor to solve. Now this is in linear first order differential equation pattern. Now if you remember that integrating factor is, we take e power, let's say mu of t right here. Mu of t is going to be e power integration of p of t dt. So p of t, if you remember the linear first order differential equation, the pattern should be we have to have dy dx, after that p of x y, and then after the equation sign you have to have another function of x y, something like that, right? So here we have this one. Now if I arrange this one in standard form, it's going to look like that: c prime minus plus 2 a cos t plus b, and after the equal sign we are going to have 2. So this is the linear first order differential equation in standard form. And if you remember, and also we have z right here, and if you remember that this value is our p of t, right? In the standard form, this is what we call p of t. Now we can go ahead and use this one to find the integrating factor, and if you plug this one in this equation, e power, we can, since 2 is constant, we can write that one in front. 2 integral of p of t is going to be this one: a cos t plus b, and if you integrate this one, that's going to give you, we know that integration of cos t is going to be sin t, so this is going to be 2, actually e power 2 a sin t plus b, right? B, and also we have to put a t right here, because when we don't have anything, integration mean that's going to be t, right? Since we have dt right here, I had to put a dt, so this is going to be bt. and this is going to be the integration of this one, and that's it. After that, what we have to do is we have to multiply both sides of this differential equation by the integrating factor. Let's go ahead and do that. So if I multiply this side, this is going to be e power 2a sine t plus bt times z prime plus 2a cos t plus b times z, and in the other side of the equation we are going to have 2 times e power 2 times e power 2a sine t plus bt. Now after we find this one, here the magic thing is the first term. If you write this one like this, like z e power 2a sine t plus bt, and if you find the derivative of this one, that will give you this one back. So that's the key things to notice in here, right? That's the reason we are taking integrating factor. In that way, this is easy to write this, right? So if this is equal to this one, we can equate this one to this one. So this is going to be equal to 2 e power 2 integration a sine t plus bt, right? Now after that, what we have to do is we have to integrate both sides, dt, and integrate in terms of t. And here what's going to happen is this integration and derivative cancels each other. So this side we are just going to have z e power 2 a sine t plus bt, and that's it. And in the other side we are going to have this one, but there's no easy way to integrate this one, right? So what we are going to do is we're just going to keep it like this. So when we cannot easily integrate, we can just keep it like this. So this is going to be integration 2 e power 2 integration of a sine t plus bt, and then also we have to have a constant, because this side usually we combine both of the constant and write it right here. Since we are not putting constant right here, we can put that one right here, right? Now what we have to do is we have to write this one in terms of y, but before we do that, we can move this e power whatever the value we have to this side. Then only we can write this one in terms of y, right? Now let's continue that part right here. So this is going to be z is going to be equal to integration of 2 e power 2 integration of a sine t plus bt dt plus constant over this value, this e power 2 a sine t plus bt. Now this is in terms of z, but initially if you notice, z is equal, because in the original function we didn't have z, we just replaced this z with this one, like y with z, because in that way we can find the solution easily. Now after we find this one, we have to switch this one back, so we have to write this one in terms of y, and we know that z is equal to y power minus 2. So if we plug this one right here, we can write y power minus 2 is 1 over y square. So we can put this one right here, or just we can directly flip this one, right? Just instead of writing like that, we can write y square is equal to this one on top, right? Let's say this one on top, e square times a sine t plus bt on top, and in the denominator we are going to have integration of Okay, here this integration sign shouldn't be there, right? Because we integrate that one already. Okay, now in the bottom we are going to have 2e square times ax sine t plus bt plus constant, right? So this dt should be right here, right after this integral sign. And now we have to square root because we had to write in terms of y. Now let's get rid of the square and write this one as y is equal to square root of this one, and that's going to be the final answer. That's going to be the general solution for this differential equation. I hope you guys find this video helpful. See you next time.